Okay, so you are clicking on that link, hopefully, in your Delta Math. We're going to 5.3. It's called Introduction to Systems, Solving Systems. So I'm going to write this down. Lesson 5.3. It really says introduction, but I'm abbreviating that. Intro to solving systems with substitution. So you're writing this at the top of your journal page. We're on a whole new journal page. This is not an insert. We're going to actually do some manual writing. I don't have some fancy colored insert for you. We're going to do some problems, okay? So this is our introduction to solving systems with substitution. So get out your journal and write this in your journal. 5.3, Intro to Solving Systems. Some of you guys don't even have your journals out and you're looking at me like, what's going on? You're not listening and I don't understand that. So 5.3, Introduction to Solving Systems with Substitution. I promise you, you're going to want this. You're going to want to have this, okay? All right, so your first question that we are going to do together, question number 1, has 2 equations. Y equals 3x and y equals negative 4x minus 49. Again, we all have the exact same problems. That was by design, okay? So we're going to use substitution. Substitution means that I take the value for one variable, like if I know that y equals 5, right? I substitute that in anywhere I see a y, okay? That's what substitution means. We take the value for one variable and we substitute it in. Well, I want to show you guys that y equals 3x. Do you see that? It says right there that y equals 3x. So in order to solve this system, I'm going to go to the next equation and I'm going to replace my y with what? With the 3x. So this becomes 3x equals negative 4x minus 49. Why are we going to do that? Well, I'll tell you why. We cannot solve an equation when it has 2 unknowns, right? We can't solve for 2 unknowns. So by substituting in that value, we now have an equation that only has one variable, x. And we can solve for that. We can absolutely solve for x. So how am I going to solve for x? What am I going to do to solve for x? I'm going to add 4x to both sides. Nice job, Ariana. Add 4x to both sides. So 7x equals, this cancels out, 7x equals negative 49. 7x equals negative 49. I'm still trying to solve for x. Divide both sides by 7. Nice job, all of you. Nice job, all of you. So when I divide both sides by 7, I find out that x equals negative 7. This is a system. Tell me what you know about the solution to a system. Because I'll tell you what I know. I know that the solution to a system is an ordered pair, right? So we just found the x value of our ordered pair. We just found the x coordinate. We know that the x coordinate is negative 7. We have to find the y coordinate. How can we find the y coordinate? What can we do with the x equals negative 7? Put it in there as an x and put it into the equation that you didn't touch. We didn't do anything with the y equals 3x. So if I let x equal negative 7 in that equation, that means I have y equals 3 times negative 7. What is 3 times negative 7? y equals negative 21. So the y coordinate of my system is y equals negative 21. So my entire solution is negative 7, comma, negative 21. Ding, ding, ding. We got that correct. Okay. Does that make sense? Okay. I'm going to go to the next question. I'm going to go to the next question, and we're going to do this one together as well. Does everybody have this work down? Raise your hand if you need more time. Okay. So let's go to question number 2. This is question number 2 that we're going to do together. Y equals negative 7x and y equals 9x plus 32. What do you want to do?
Move the negative 7x where the y is.
Yeah, absolutely. So we're going to rewrite that second equation as negative 7x equals 9x plus 32. Negative 7x equals 9x plus 32. So how am I going to get x all by itself? Yeah, you can both talk. That's good. Subtract 9x from both sides. Excellent. So a negative 7 and a negative 9 give me a negative 16. Negative 16x equals positive 32. Absolutely. We're going to divide both sides by negative 16. So x equals negative 2. Remember that this is a system, and I know that my solution to a system is an ordered pair. We just know the x coordinate. We know that x is negative 2. How am I going to find y? Make the x in the first equation negative 2. So y equals negative 7x, but I'm going to replace that with a negative 2. So y equals negative 7 times negative 2. What is negative 7 times negative 2? So y equals positive 14. So my solution to my system is, yeah, go ahead, say it. Negative 2, positive 14. Excellent. You guys are doing great. So anyone need this still? Yes, you still need that up there? You're good, Kenna? Okay. So let's do question number 3. And I'll post this video and our filled out notes. So if you missed a question, you can go back in there and get it, okay? So number 3, our question is y equals negative 7x and y equals negative 5x plus 10. Someone different, someone who hasn't shared it all. Like Tim, what do you want to do?
Make the negative 7x, or move the negative 7x where the y is.
I love that. So I have negative 7x equals negative 5x plus 10. So if I want to get x all by itself, Aiden A, what would you do if you were trying to get x all by itself? Yeah, good job. We would add 5x to both sides. You guys are doing so awesome with this. So negative 7 and a positive 5 give me a negative 2x equals 10. Okay. Ken, if I want to get x all by itself, what am I going to do? Avery. Yeah, divide both sides by negative 2. Divide both sides by negative 2. So x equals -5. X equals -5. But I remember that every solution to a system is an ordered pair. You guys are going to get so tired of hearing me say that, but I'm gonna. So I know that the x-coordinate is -5. The x-coordinate is -5. Victoria, how do you want to find the y-coordinate? Plug in the x value. Do you guys see that? We're going to plug that x value in. So y equals -7 times -5. Well, what is -7 times -5? It's +35. So my solution to this system is -5, comma 35. -5, comma 35. What are y'all thinking about this? Easy? Okay. I'm going to try one that looks a little bit different. Question number 4 looks a little bit different. Is this question number 4? Or is this 5? 4. Okay, thanks. So my first equation, 7x minus 3y equals 8. My second equation, y equals 3x. What have we been doing? Yeah, so I replaced the y. I replaced the y with 3x. So let me draw an arrow and show you what's going to happen to that. So really, that -3 outside of it is still going to stay there, right? So I have 7x minus 3 times y. Well, I'm replacing y with the expression 3x equals 8. So now we have to do a little bit of multiplying before we simplify this. 7x. What is -3 times 3? -9x. We're multiplying. Equals 8. What is 7 minus 9? -2. Good job. So -2x equals 8. Divide both sides by -2. X equals -4. Remember that every solution to a system is an ordered pair. I know the x coordinate. I need to find the y coordinate. How am I going to do that?
Just do y equals 3, 6, and then y equals 3 times -4.
Good job. Right. Y equals 3x, and then replace that x with a -4. Awesome. What is 3 times -4? So y equals -12. So my solution should be -4, comma, whoops, I forgot my negative, -12. Okay. Did we try it? How do we feel about that? Okay, let's try one more funky one. So this is going to be question number 5 that we're writing in our journal. Question number 5. All right. X minus 6y equals 22. And x equals -5y. Do I have a variable all by itself? Do I have a y equals or an x equals? I have an x equals. What does x equal? Yeah, so I'm going to take this value of -5y and I'm going to plop it over here where x is. The reason I put in an equation like this is because you guys get so consistently are substituting in for y that when you have to substitute in for x, you're like, whoa, wait a second, what's happening? Same process, we're still using substitution. So now we're going to manipulate this equation. X, which is negative 5y minus 6y equals 22. What is a negative 5y and a negative 6y?
Also 30y.
We are not multiplying. That's a subtraction sign. It's negative 11y. We're not multiplying, we're adding. Same signs, add and keep. Equals 22. What am I going to do next? Yeah, divide both sides by negative 11. Divide both sides by negative 11. Y equals negative 2. I know that the solution to every system is an XY ordered pair. Where's that negative 2 going? Well, yeah, but I mean, in my ordered pair, where does the negative 2 go? In the second spot. Good job. That is probably the second biggest mistake I see. You solve for y, but you put it at the front, okay? It's kind of tricky, right? You got to pay attention to what variable you're solving for. Okay, so we're going to take this negative 2, and we're going to plop it in right there. So I'm going to rewrite the original. X equals negative 5 times y, and then I'm going to do the substitution. X equals negative 5 times negative 2. What's a negative times a negative? A positive. So x equals negative 10. No, positive 10, sorry. X equals positive 10. So where's that going to go? Plop it right there. So my solution for this one is 10 comma negative 2. If you drop your negative, it's going to tell you you're wrong. Get back in there and fix it. Okay? Alrighty, so I'm going to go back to this so you can see what your homework is for the weekend. You have 6 questions of the just replacing one y and substituting in for another, okay? 6 questions like that. And then I gave you three questions that are a little bit more like this, these last 2 examples. 6 plus 3 is 9, plus we did 5 examples. And I wanted to give you some bonus. So this is going to be a 15-point assignment, okay? You feel good about it? Okay.